Welcome back to NCX Math after a long time, and from now on I'm going to continue a series on real analysis, so please subscribe the channel. And today in this video I'm going to prove a theorem. Every open ball in R is open in R. So here I'm going to prove that the open ball, say BCR, this is the open ball with the center C and radius R, and I'm going to prove that this ball is an open ball. So we simply can write this ball in an interval form as C minus R to C plus R, this open interval, and I'm going to prove that this is an open set in R. So for this we suppose X to be an element of this set, BCR. We suppose X belongs to this open ball BCR, and I'm going to prove that this point X is an interior point of this open ball. So for this I'm going to find another ball which completely lies inside this open ball, and since we have X belongs to this open ball, so we should have modulus of X minus C. This should be less than R. It is because X lies inside this ball, that's why. And now we are going to suppose we're going to suppose another variable, let's say R0, and this to be R minus modulus of X minus C. So this is basically the difference between these two quantities, R and X minus C, and it's very clear that since R is greater than X modulus X minus C, so we must have this value R minus modulus of X minus C. This is a positive value. It is very clear from this fact. And actually we're going to prove, actually we're going to show this thing. We'll show that this ball with center X and radius R naught, this will completely lie inside our original ball BCR. Okay, so we're going to show this, and this will prove that this point X is an interior point of this open ball BCR, and which will prove that BCR is an open set. So for this, since we are going to prove this, so I suppose Y, there's let's say another element Y, and it belongs to BX R0. Okay, and eventually I'll show that this Y also belongs to this open ball BCR, and this will prove our theorem. So I've supposed Y to be an element of this ball X BX R0. So since Y belongs to this ball, so we must have the distance between X and Y, that is modulus of Y minus X, and this is to be less than R naught or R0, and this is by the definition of an open ball. And now since we have to prove that this Y lies should lie inside this BCR, that's why I'm going to find out the distance between Y and C. Okay, that is Y minus C. So for this here I'm going to write it as Y, let's say Y minus X plus X and then minus C. So I've subtracted and added this X, and now we can use triangle inequality, considering these two as two different elements. So as we separate this absolute value sign, so we should get less than or equal to modulus of Y minus X plus modulus of X minus C. and this is because of triangle inequality. We can write down the reason here. This is due to triangle inequality. And now finally, there we have already derived that the distance between y and x here, this is less than r0, and the distance between, we are just going to need this. Okay, so we can simply write that y minus x, modulus of y minus x, this is less than r0, and we are going to write modulus of x minus c as it is. Okay, and now we have got the value of r0 here, and that is r minus modulus of x minus c. So we are simply going to replace the value of r0, and this is r minus modulus of x minus c, and we have remaining modulus of x minus c there. So now simply we can cut these two values. Okay, so now we get r. So finally we got modulus of y minus c, and this is here we have less than, modulus of y minus c is less than r, and this clearly implies that this y belongs to the ball with center c and radius r. So this is what we needed to prove the theorem. So we suppose y to be an element of this open ball bx r0, and finally we got that y belong to here in this open ball bcr. So we now can finally say that b, ball with center x and radius r0, this lies inside bcr, and this proves that this x is an interior point. X is an interior point of the open ball bcr. So since all the elements of bcr is an interior point, so we can say that bcr, that is the ball with center c and radius r, this open ball is an open set. So that's all for today. So I hope you found this video useful, and if you have some confusion, you can comment down below. So thanks for watching. Have a nice time.